Welcome back. This is part 2 of Chapter 1 review. If you're a newbie, welcome to numbers 10 through 19 in this video. Let's just start out with number 10 here. We look at a picture. We see Q is between R and V. First statement says Q bisects VR, so these two would be congruent. We mark our picture that QV is x squared minus 2x minus 3, and QR right here is 1 minus 5x. So since we have both pieces, they're both the same size, we're going to set them equal. Say x squared minus 2x minus 3 is equal to 1 minus 5x. Since I see an x squared, I'm going to have to factor, so I'm going to bring everything over to the factorable side. Add the 5x over minus the 1. So now this equals 0 like we wanted to. So we have x squared plus 3x minus 4 equaling 0. Leading coefficient of 1, so we can go to our shortcut of x and x here. We need two numbers that multiply to negative 4, but add to 3. So it looks like a positive 4 and a negative 1 to me. So this answer is negative 4. This answer is positive 1. Maybe both work, maybe they don't. If I plug in for QR, the 1 minus 5 times 1, this is 1 minus 5, which equals negative 4. So the 1 doesn't work. So the only one that does work is the negative 4 for that answer. Moving on. Number 11. This is bisected. So both of these two pieces are congruent to each other. If that's the same thing, we can do 3x squared minus 4x equal to x squared minus 9x plus 3. Once again, factorable, so we move everything over to make it equal to 0. So we have 2x squared plus 5x minus 3 equals 0. No leading coefficient of 1, so we have to do it the long way. Bring down the 2x squared, bring down the 3. We need 2 times negative 3, so we had two numbers that multiply to negative 6, but add the 5. Looks like 6 and negative 1, so negative 1x, positive 6x. We group. This first group we can pull out an x, leaving with 2x minus 1. Second group we can pull out a 3, leaving us with 2x minus 1. And we have it right because we have 2x minus 1, and we have x plus 3 equaling 0. So what do we get? We get negative 3 for this answer, and we get a positive 1/2 when we set it equal to 0. Now we have to check to see if both work. So plugging them in back up into our angles here, if we plug in the half up here, we do 3 times 1/2 squared minus 4 times 1/2, and we end up getting negative 1.25. So this time the 1/2 doesn't work, so that means the negative 3 has to work for it, and you can check it out by plugging it back in. When you do plug it back in, because you want ABC, so you want the big angle, and you plug it back in to 3 times 3 squared minus 4 times 3. Well, this is 3 squared, 9, so that's 27 minus 12, giving you your answer. Sorry, negative 3 in here. So you're getting 27, and then this is a negative 4 times negative 3, so plus 12. So that's 39. And 39 here, and 39 here adds to equal angle ABC, which is 78 degrees. Number 12 is a clock problem, so we get out our idea of drawing a clock. How much is between each number? Hopefully you said 30. Whereas the big hand, if it's at 150 on the 10, Whereas the little hand, somewhere between the 1 and the 2. Which hand is it closer to? The 2. All right, now we have to decide, are we counting our 30s clockwise or counterclockwise? Start from the big hand towards the little hand. Clockwise, so that's great. We got 30, we have 60, we have 90. So we know it's at least 90, and then we're going to be adding the extra piece for our final answer. So what do? We take our minutes over 60, times it by 30. That's 5/6 times 30. End up with our answer of 25. And because we count it clockwise, we just add this part to it. So we add the 90 and the 25, giving us 115 degrees for the clock between 1:10. Number 13, I look at it right away, see X's and Y's, looks like a system. BC's trisects, so these three pieces are congruent. So we get 4x plus 5y, we get x plus y plus 8, and we get 3x plus 3y. So I'm going to set 2 equal to each other and another 2 equal to each other. You could technically get 3 equations here, but you only need 2. So you get 4x plus 5y equaling x plus y plus 8. Okay, that's one equation. That's AB and BC equaling each other. Let's simplify this one. Minus x minus y over. So we're technically getting 3x plus 4y equaling 8. And the other equation over here that we can do would be 3x plus 3y equaling x plus y plus 8. So we minus it over, and we get 2x plus 2y equaling 8. Okay, to me, let's get rid of the y's. So we're going to multiply that one by negative 2. And we're going to get negative 4x minus 4y equaling negative 16. And then we rewrite the top one where they cancel each other out. So this is negative x. Over there is negative 8. So x ends up equaling 8, which is your answer in the back. Plug it back in for your y. And y ends up equaling negative 4 when you plug it back into any of these two equations for it. Now you want to find BD. Well, from B to D is 2 sections. So if we plug it back into one section, so we'll do 8 plus negative 4 plus 8 again. So we end up with 12. So from B to C is 12. I mean, C to D is 12. So BD ends up equaling 24. Continuing on, 14, it says trisected, so all 3 of these pieces are congruent to each other. What do you notice from the picture? Scroll up a little bit. All right, is all 3 are congruent? Ooh, I like this 25 here. That makes my life a little easier because I could set 5x minus 3y equaling to 25. And I could set my second equation of 7x minus 2y plus 1 equaling to 25. This one's already done. This one, if we minus the 1 over, we get 7x minus 2y equaling 24. Now it's lined up x, y number. Rewrite the second one. 5x minus 3y equals 25. Before we can minus anything, let's do the top by negative 2, the bottom by 3. Negative 14x plus, sorry, top one by negative 3, bottom one by 2. Jumping the gun here. Hang on. So we get negative 21x. We get positive 6y. And we got negative 72. Bottom is 10x minus 6y equaling 50. These cancel out. We get negative 11x equals negative 22. So x ends up equaling 2. Plug it back in to any of the equations. So if I plug it back in and I get y ends up equaling negative 5. Number 15. Looks like we got all 3 sides here. 3x minus 10, x plus 4, and x squared minus 5x plus 6. All those have a perimeter of 30, so we're going to add it all up. In my head, I see an x squared, 3x, x, and negative 5x. To me, that's negative x, negative 10, 4, and 6. 4 and 6 make 10, and negative 10, so that's 0, equaling 30. Can't factor until it equals 0. Minus the 30 over. Now we can factor. Leading coefficient of 1, so jump into x and x. Multiplies negative 30, but adds negative 1. We're going to have a 5 and a 6, but we need a negative 1, so we'll give that one negative, this one positive. So this answer is negative 5. This answer is 6. When we plug it back in, if we do 3 times negative 5 minus 10, we're at negative 25. So negative 5 doesn't work. 6 is the x that works. Find the longest side. You plug them back in, and to me, AC ends up equaling the longest side. Not because of the picture, just because when you plug it back in, and you end up with the 6 squared minus 5 times 6 plus another 6. So we end up with AC equals 12. Continuing on, we got a couple more left in this video. Number 16, we could see that where they are, they equal 160, so we're going to add them up, 4x and x, so that's 5x squared. We got 2x and 3x, so that's plus 5x. 64 and 36, looks like we're at 110, equaling 160. Before we can move on, we're going to have to set it equal to 0. Sorry, 100. We're going to set it equal to 0, so we're minusing the 160 over. So we got 5x squared plus 5x minus 60 equaling 0. Before I factor, I see I could pull out a 5, leaving me with x squared plus x minus 12. Don't worry about the 5. We can go to leading coefficient of x and x. What gets me there? It looks like 4 and 3 on a positive one, so 4, negative 3. So then my answers come out to be negative 4 and 3. Don't worry about the 5 in front, it's just there. And look at this. If I plug back both of them in, this time both do work. In 17, you got to ask yourself, what am I looking for here? So this angle wants to be obtuse. So we're taking this piece and we're making it into an obtuse angle. Well, what do you know about an obtuse angle already? That's right. It's between 90 and 180. So we take this piece, plug it into the middle portion. 90 is less than 3x minus 30, which is less than 180. You solve it algebraically, adding 30 everywhere. 120 is less than 3x, which is less than 210. Divide by 3. 40 is less than x, which is less than 70 for our answer. Almost done. We're getting there. Number 18, same expression, but this time we want it as an acute angle. So acute angles go from 0 to 90. Plug this guy in the middle. 0 is less than 180 minus x, which is less than 90. Minus 180 everywhere. We got negative 180 is less than negative x, which is less than negative 90. Divide by negative 1. 180. Flip the sign because you divided by a negative. I don't see this answer there, but I see its counterpart because when you have this, you always want to rewrite it with the arrows pointing to the left. So you flip everything. So my answer choice is Z. That was challenging. That is what is on the ACT. That question was actually on a real ACT. That's where I got it from. Number 19, we have a triangle. We want to know what side lies between. Well, our rule is the two smaller sides have to add to be bigger than the third side. So if you use 25 as the biggest side, you can say 25 minus 16, giving you your answer of 9 of being the smallest value. Or maybe this is the biggest side, so you do 25 plus 16, giving you your answer of 41. So 41 could be the biggest side. Hopefully this is doing well for you. Goodbye.